Beautiful morning, children. You are welcome to Divine Offspring Virtual Classroom. And our subject today is mathematics. Okay, today in mathematics, we will be looking at a very interesting topic, although we've been on this topic for the past 2 weeks. And let's see what we have. Today we'll be looking at probability. And under probability, we'll be looking at probability without replacement. Last week, we talked about probability with replacement. Okay, then these are the following materials you will need. You will need the following materials. You will need a book, you will need a pen, and you also need your brain. And I'll need you to be in a conducive environment that is a kind of room that is quiet. Okay, now let's see a quick walk. I need you to quickly answer this. A coin is tossed 10 times, a head is recorded 7 times, and a tail 3 times. What is the probability of getting a head? Okay, I need you to quickly solve this. Pause and solve this question. Okay, let's continue. The probability of getting head is equal to 7 over 10. That means the 7 times divided by the total outcome. Okay, now see another one. Go toss a dice once in an experiment. What's the probability of getting a 2? Let's see. You can pause to answer. Okay, let's continue. We have probability will be equal to 1 over 6 because 2 occurs just once in a dice. Okay, now a quick recap on what we treated last week. We said theoretical probability is the method to express the likelihood that something will occur. It's the method to express the likelihood of that something will occur. We talked about this last week, and we also said that theoretical probability is calculated by dividing the number of favorable outcomes by the total possible outcome. Okay, and last week also we learned that the formula for probability or theoretical probability is the numbers of favorable outcomes divided by the total possible outcome. We will be making use of this formula in our next work. Okay, now let's look at probability without replacement. Probability without replacement. Now, when we talk about probability without replacement, it means that the item picked is not replaced. The item that is picked is not replaced. Unlike with replacement, I said the item picked is always what? Replaced with another one. Then here in probability without replacement, the item that is picked is not replaced. Now, when an item is picked without replacement, that means there would be a reduction of the total number. Now, let's look at this. We also said that and or is you make use of what? Plus. Then anytime you see and or you see or in a question, you do what? You add. And anytime you see not, you do what? You add the others. Okay, now let's look at this to explain probability without replacement. What I actually mean by without replacement. Now that means that when a ball is picked, you can see that the blue ball is picked without what? Replacing. Now we can also see the red one is picked without replacing. The black one is also picked without replacement. Now from this you will see that the more a ball leaves the total balls, there's actually a reduction in the total numbers of the balls, right? Okay, now let's look at this example. In a bag, Moses picked 3 yellow balls, 4 blue balls, and 6 black balls. If a ball is picked at random without replacement, what's the probability of picking a blue ball? Also, what's the probability of picking black balls? The third one, what's the probability of picking yellow balls? I recap. In a bag, Moses picked 3 yellow balls, 4 blue balls, and 6 black balls. If a ball is picked at random without replacement, what is the probability of picking blue balls, black balls, and yellow balls? Okay, now we have to arrange our balls. We have 4 blue balls, we have 6 black balls, and we have 3 yellow balls. Remember, the probability of picking the first one, which is the blue balls, we have probability is equal to numbers of favorable outcomes divided by the total possible outcomes. Now, the probability of getting the blue balls, we have 4, because we have 4 balls divided by what? 13. Then for you to pick the first ball, the total number still remains the same. But when you want to pick the next ball, the total numbers of ball, or the total possible outcome, will be reduced by 1. Is that taken? Okay, now we've taken that the probability of picking a blue ball is equal to 4 over 13. Now let's look at the second one, the probability of picking the black ball. Probability of picking black balls. Now doing that, remember what I said, the total numbers of black balls still remains the same, but the total possible outcome will definitely do what? Reduce by what? By 1. Now what do we do? There's 6, that's the total numbers of black balls we have there, divided by what? 12. You can see it has reduced, right? Okay, then let's go to the next one. Probability of picking yellow balls will be equal to, how many yellow balls do we have there? 3, right? Now over what? Total possible outcome. That means picking a yellow ball now, the total numbers will do what again? Will reduce by 1. Then what do we have? Over 11. Then if we had another ball, for example, if we add another question to the question there, maybe you were asked to find the probability of picking another red ball. That means if a red ball was part of the total numbers of balls there, that means if I'm to pick a red ball, the total number or total possible outcomes will also do what? Reduce by 1. If you still do not understand, I'll need you to pause this video and play again. Okay, now let's look at another question. In a box, there are 9 bottles of different colors. If 3 are yellow, 4 are blue, and 2 are green. If a bottle is picked without replacement, what is the probability of picking blue bottles? And the second one, what is the probability of picking green bottles? In a box, there are 9 bottles of different colors. If 3 are yellow, 4 are blue, and 2 are green. If a bottle is picked without replacement, what is the probability of picking blue bottles? And the second one, green bottles. Now what do we have? Numbers, probability is equal to numbers of favorable outcomes divided by the total possible outcomes. Then what do we have? The total numbers of bottles there are 9. We have 9 bottles, 4 blue balls, 3 yellow bottles, and 2 green bottles. Okay, then we have probability for blue is equal to what? We have how many bottles for blue? We have 4 blue bottles. And we have 4 over 9, because the total numbers of bottles we have there are actually what? 9. Now to pick the second one, which is green bottles, the total numbers of, or the total possible outcome will reduce by what? By 1. Now let's go to the next one. Probability of getting a green bottles will be equal to what? 2 over what? Over 8. You can see that reduced because blue had been picked out. Then that will reduce what the total numbers of bottles right there, right? Okay, then we can actually divide this further. 2 divided by 2 is 1. 2 in 8 is 4. Then we have 1 over 4. If you still do not understand, please, I'll need you to pause to play again. Okay, I guess and I believe you enjoyed this lesson. Remember, the only way to learn mathematics is to do mathematics. I remain Mr. Etim Emmanuel, and I say a big bye to you till I come your way next week. Attached to this video is actually a worksheet on this lesson. Have a blessed day.